We've seen how to describe a single quantitative variable, but here we're going to see how to understand the relationship between two quantitative variables. And the things that we're going to look at here are called the sample covariance and the sample correlation coefficient. And these are different measures of association that we can use to describe the relationship between two variables. So the sample covariance measures the direction of the linear relationship between two variables. And in Excel, we can use the command covariance.s. The .s here is for sample. And the value that we get from the sample covariance, it tells us the direction of the relationship, but it's hard to interpret to understand if that means there's a strong or weak relationship between those two variables. And so we use something called the correlation coefficient that can measure both the strength and the direction of that linear relationship. And in Excel, we can use correl to find the sample correlation coefficient. So let's take a minute to understand what this correlation coefficient means before we switch into Excel to do an example. So if we look at a scatter plot, and we saw how to make scatter plots earlier, we could have a situation where the variables on the x and y axis don't have a clear linear relationship. So here, if I look at this situation, I have all of these points. It's not clear that there's a linear relationship between these two variables. And I could make this even more kind of looking like there's not really a relationship between them. In this situation, the sample correlation coefficient is given on the bottom of this image. Here it says it's about 0.06. That's close to 0. That means there isn't really a linear relationship between the variables. But if I make the data look something like this, now it looks like as x gets bigger, it looks like y gets bigger, and this is kind of happening in a linear way. And so this correlation coefficient is getting bigger and bigger. And if I have a perfect linear relationship that's positive, my correlation coefficient is 1. And if I have a situation where it's maybe not perfect, but a strong linear relationship, that correlation coefficient will be close to 1. And if I go the other way and have this be a perfect negative linear relationship where the slope is negative, the correlation coefficient will be -1. And so things where I have a correlation coefficient close to 0, that means that I don't have a strong linear relationship between the variables. So let's take a look at this next exercise. This says a regional manager at Acme Markets would like to develop a model to predict weekly sales of pet food based on the shelf space. And the data in the Excel file shows the results collected from 9 randomly selected stores. So we want to find the sample covariance, the sample correlation coefficient, and then use those to say something about the relationship between x and y. So first, let's find the sample covariance. So in Excel, we could do covariance and then .s for sample, and we want to put in our two variables without the titles. And it doesn't matter here which comes first. I did column A and then column B, so shelf space and then sales. But if we did this the other way around, covariance.s, if I could first do sales and then do shelf space, and this should give me exactly the same thing. So this being positive tells me that as sales go up, shelf space goes up, or vice versa. So I would think of this as if shelf space increases, the sales increase. So they might want to know, if we dedicate more shelf space to pet food, will our sales go up or not? And this is telling us it seems like there's a positive relationship. If shelf space goes up, we expect sales to go up as well. And let's find now the sample correlation coefficient. So far, we've seen the sample covariance. That's positive, so we know there's a positive linear relationship, but so far we don't have any idea how strong it is. We just know that it's positive. We don't know if it's a strong or weak relationship, and that's where this correlation coefficient comes in handy. So if I do correl and put one column and then the other, okay, so this is also positive, which is good. It matches with the sample covariance being positive, but this isn't particularly close to 1. So this is about 0.54. It's kind of halfway between 0 and 1. And so I would say that since R, our sample correlation coefficient, is almost exactly in the middle of 0 and 1, I wouldn't say there's a particularly strong relationship between these variables. I would say there is maybe a moderate positive relationship between shelf space and sales. And to visualize the relationship, we could make a scatter plot. So if I highlight these variables, go to Insert, and insert a scatter plot, I would want to add axis titles and all of that, but it looks like shelf space is the x-axis and sales is the y-axis. And sure enough, it looks that kind of in general, as shelf space goes up, it looks like sales tends to go up, but this is not a perfect or very strong linear relationship. And so this might help you decide how much shelf space to dedicate to pet food. You can get an idea of what the sales were when different amounts of shelf space were dedicated to pet food, and you can use that to decide what you want to do. And so if we had gotten a negative correlation coefficient, that would have told us that as x gets bigger, y gets smaller. And so that would have been a negative correlation. Here we had something positive, but it wasn't particularly close to 1, so it indicated a moderate relationship.